Hey there, I'm Joe Carter. If you've ever popped the hood and thought, where do I even start? You're in good company. Around here, we take the mystery out of car repair, one fix at a time. Whether you're a beginner or just looking to sharpen your skills, there's something here for you. Don't forget to like the video and subscribe if you're into learning without the headaches. All right, that's enough from me. Let's get into it.
Knowing that an internal combustion engine runs on air is fundamental to understanding the purpose of turbocharging. The wording is just that, because supplying fuel to the cylinders is not a problem at the current stage of technological development. Technically, it is very simple to realize an extremely productive gasoline pump, fuel injector and fuel injectors. Supply of oxidizer to the cylinders in an atmospheric engine, air is drawn in due to the rarefaction that occurs as the piston moves toward bottom dead center, BDC. We have a certain ideal amount of air that can fit into the cylinder, limited by the volume of the cylinder. In reality, due to all sorts of losses, the cylinder is only filled to 70 to 80% of its volume. It is at this point that the main purpose of turbocharging is revealed, to force air into the cylinders. Using a turbocharger, we can not only fill the cylinders completely, but even exceed this figure by supplying pressurized air. And this leads to an increase in density per unit volume and, consequently, an increase in the total mass of the air charge. Types of turbocharger: a turbine that is driven by the energy of exhaust gases. The turbine can be conceptualized as two fans that are located on the same axis. One of the fans is connected to the exhaust system of the vehicle, the other is located in the intake tract. The gases leaving the cylinder at the exhaust stroke drive the turbine wheel. Since both fans are mounted on the same axis, the compressor wheel in the intake tract also begins to rotate, thus accelerating the passage of air. The higher the engine speed, the greater the exhaust pressure in the intake tract. And the higher the exhaust pressure, the faster the turbine wheel will spin in the intake tract. Accordingly, more air can be pushed into the cylinders, more fuel can be supplied, and more exhaust gas can be generated at the exhaust. The principle of operation is discussed in detail in the article, Turbine Device on Fingers. Mechanical supercharger, also known as supercharger or compressor. The supercharger is spun by a drive belt from the crankshaft pulley. Therefore, the exhaust gases are not used in any way in the operation of the compressor. Turbine. Obviously, it is enough to look at the photo to understand the device. The principle of turbocharger operation is also quite clearly demonstrated in the video. In more detail, let's dwell on the bypass valve and the purpose of the intercooler, which is mandatory for the effective operation of a turbocharged car. At the moment of sharp closing of the throttle at high engine speeds, a strong pumpage is created in the intake tract. The compressor wheel of the cold part inlet of the turbine continues to rotate by inertia, creating excess pressure in the channel blocked by the choke. There is a sharp deceleration of the compressor wheel, and this automatically leads to slowing down of the turbine wheel in the exhaust duct and creating a strong opposition to the exhaust gases. A bypass valve is designed to prevent this effect. It either relieves the excess pressure to the atmosphere, blow off, or redirects the flow back to the inlet in the direction of rotation of the turbine wheel. Bypass intercooler in the turbocharging system is designed to cool the air flow. When the temperature rises, the density of the air decreases, which leads to a decrease in mass per unit volume. System characteristics: turbine performance features, most efficient in high and medium RPM. Very low efficiency up to a point called boost. Further worsens the situation by reducing the compression ratio to prevent detonation. This is why autos with a single-stage turbocharging system have turbo lag, or turbo lag. In one way or another, there is a counteraction of exhaust gases at the exhaust. This slightly worsens the efficiency of the engine, although in general turbocharging allows you to increase the power of the engine. The demands on the quality and frequency of engine oil changes increase. Features of mechanical superchargers: there is no inertia inherent in a turbine. The injection of additional air charge increases in proportion to the increase in the number of revolutions of the internal combustion. engine and continues until the moment of flow disruption from the blades. They are most effective in low and medium RPM mode. Slight decrease in engine efficiency due to additional friction losses. Operation: the turbocharging system is most common on diesel engines. High-end engines often use two-stage supercharging systems, biturbo, one small turbine for power gain at low speeds and a large turbine for high speeds. Turbine plus mechanical supercharger. We considered the design and principle of operation of such a system on the example of TSI engines from Volkswagen Group. In conclusion, turbocharging represents a remarkable advancement in engine technology, enhancing both performance and efficiency in gasoline and diesel engines. By harnessing the energy from exhaust gases, a turbocharger significantly increases air intake, allowing for more fuel to be burned, and resulting in greater power output without a corresponding increase in engine size. Understanding the intricate components and operation of a turbocharged system reveals how it optimizes engine performance while maintaining fuel efficiency. As we continue to innovate in automotive engineering, turbocharging will undoubtedly play a crucial role in shaping the future of high-performance, environmentally friendly vehicles. Thank you for joining us in exploring the fascinating world of turbocharging in theory and practice.